AG6AG, AG6AG, AG6AG. Yeah, there's no parking and lights on. Okay, random metal objects on the air. This has changed a little bit from December when I was going to do this, and then I got sick and I couldn't do it. So for various reasons that don't need explaining right now, I'm not going to do any HF transmitting in this room tonight, because there's something that we might interfere with, and it ain't going to be me that does it. So whatever will be planned with, we'll be dealing with SWR, which a lot of people think tells you whether it's an antenna or not. And it doesn't, but it's a good clue. And then Sunday at Micro Field Day, we can start loading some stuff up and blow up radios and do all kinds of crazy stuff down at the airport. So we also had a couple of people that are famous for this, so we're going to bring stuff by tonight, and they couldn't come at the last minute. So the toaster oven, I'm afraid, is not here. And who saw the toaster oven? And who's just heard about the toaster oven? One more hands, yeah. Who never raises their hand for these kind of things? Yeah, the toaster oven was Ben. It was pretty famous. It was a fantastic 20-meter radio. And I wish I could tell you this was a lie, that we're making it up to sound funny, but you really could adjust the SWR by pulling the crumb tray in. It was terrible. And when I first walked up and saw him talking to somebody, it was somebody in Colorado, and they were 10 over. Awesome. Antennas are really, really, really complex, and hams love nothing more than to take a complicated subject and keep it that way. Right, Stu?
Oh, yeah. So tell me, on the SWR of 2.5, what's the actual dB drop across the receiver?
Depends on the toaster setting.
Thank you, Jeff.
It's in our script. Good work. No, the thing is with antennas, they are really complex. And if you want to build a $20 bazillion contest station, you better be really good at getting all the math right. If you want to do commercial broadcasting, you really have to know it all. If you want to be a ham, nonsense. Antennas are ridiculously simple. In fact, anything that's conductive can't help but being one. Greg walked up with this metal bar. At Bozo's frequency, it's 1.2 to 1. There's an antenna.
Does the low SWR mean it's resident?
It suggests that it might be. What it means is the SWR is just telling you that out of all the energy you're putting into it, how much of it's coming back.
Right.
Now, a resistor isn't going to send anything back, so a dummy load.
So what's residency?
Resonance is essentially the energy you're sending in from your radio is going to get converted into radio energy out in the universe.
So it's a measure of residency, it's SWR.
Well, sort of. Yeah.
Right.
Yeah.
But you said it was simple.
Yep. Because there's so much of this we can ignore. The reason we're going to care about SWR isn't to know how good the antenna is going to be. It's just to keep your radio happy. Your radio doesn't like to have all the energy reflected back into it. Tube radios, it didn't matter because, the thing you do balancing a tube radio before you transmit, that's your antenna tuner. You're always matching the radio to the antenna. With solid state radios for a while, with the transistors, people would have a bad antenna. They'd overheat the output transistors. It would blow up. There was a phrase called blowing your finals in the 80s and 90s that was real popular.
I did it in the 2010. Yes. Several times.
He wasn't even a ham before. Modern radios now, if they detect too much power coming back or a bad SWR, they'll cut your power. So even the radio I carry around for portable, it's 20 years old, but if I put a bad antenna on it, or if I get too goofy playing with these, it's not going to hurt itself. It's just, it'll end up being a 5-watt radio instead of 100. So SWR Yes, important. If you're gonna play with random antennas, yes, you need an antenna analyzer. Because you can damage equipment. This is Ed's antenna analyzer. I have the same one and yesterday morning it broke. These are sad ham noises I'm making. So thank you, Ed, for letting me use it. We'll have lessons some other day on how to use one if you want. Especially at places like Microfield Day. So. Greg, I'm not sure how we were supposed to set these up as the counterpoises. Because my coax is the counterpoise. Mm. And we're gonna cover why in a minute. We're really gonna get simple here. Who knows what that's for?
Choke.
Choke, that's right. It's not a balun. It's choke. It's to keep any stray RF on the outside of my coax from getting into my radio. It doesn't stop at all. It just improves the odds you favor. You shouldn't ever need one. You should always use one, but you should never need one. If you're getting RF in your shack, this isn't how you fix it. This is the wrong thing to do. The thing to do is to stop getting RF in your shack.
Oh, yeah, right.
Come on.
Again, if you've seen all of this, I'm going to oversimplify it, so you won't like it. A little less feedback. There's our plain old dipole. You've seen pictures that show what the voltage looks like. You know, this is going to be a quarter wave of wherever this thing is resonant, where it works best. There's a funny thing about radio waves. If they're flying around through the universe and they come across something conductive that's a quarter wave, they really, really like it. And they're going to turn into a current in your antenna. That's a real simplified way to put it, but there's nothing to argue with about it. And the next thing they're going to do is they want to, it's a quarter wave, quarter of a sine wave. Everybody see that? The next thing it wants to do is find a mirror image of that quarter. We usually give it to it with a dipole. It's the other half of the dipole. So we call a dipole a half wave antenna, a quarter wave plus a quarter wave. If you don't give it that, it's going to take it from somewhere or it's not going to resonate at all. Usually takes it from the shield in your coax. Who has an in-fed antenna? You don't, you have a dipole. Your coax is the other half. There are very few in-fed antennas, and they're like zap antennas and J-poles, which are pretty cool. But if you're getting RF back in the shack, it's because you don't have enough coax there to let this get its mirror image. So it keeps trying to take it out of the shield of the coax, which is connected to the case in your radio. It's still trying to take it out of that, take it out of the ham, take it out of the monitor in your computer, whatever. So RF in the shack is a sign that you didn't give enough counterpoints, which is what we call this second half. So if we're trying to do random metal objects, all we need to worry about is finding this and making sure we have some coax. So, real simple. That way you can take some remarkably random stuff and actually make a pretty good antenna out of it. Everybody loves old Heathkit radios, right? This is a real strange one. It's a 2-meter AM and CW only with a separate two VFOs for receive and transmit. And people might be wondering just how good of a radio it is. And I figured that was the wrong question. Oh yeah, I don't know how to use this dang thing. Here we go. Oh, this is too finicky for me to tune it in and show you.
So I'd help if you hook the coax to the analyzer.
That would do it. Step one is to remove the high. Yeah. You almost had the terminology right. What I needed to do was remove the high impedance air gap.
I like
The problem that's in between technician and equipment.
Yeah, that problem exists between you. And, well, sparing you looking at me playing with the analyzer the whole time. It's about 1.8 to 1 on the middle of the 20-meter band. I made a contact yesterday on it in Oregon, 20 meters.
Using it as an antenna.
That's the intent.
Yeah.
Yeah, so as a radio, it's probably not really very good, but it's not a bad antenna.
How much power are you using?
I wasn't running full power on my radio, maybe 50 watts. But yeah, I could have run more. Now, it sounds really funny to use this on it if you really know what's going on here. Most of the antenna's right here. And the transformer in there. And it's not connected to anything past that. And if I put it over on the other plug, leg of the plug, it's not as good.
Is it better if it was sitting up on the roof?
Probably, yeah.
So height is always king, right?
Not king, height is always handy. But height is never critical.
And it also depends on the kind of antenna that you're running,
Yes.
how it's polarized.
Mhm.
There's a little bit of science.
Yeah.
Regardless of
Right.
how we try to
Yeah,
play.
you lose some efficiency and you can get some weird patterns if you don't have height. But again, we're not talking about a permanently installed antenna for our
Right.
houses here. We're talking about something you can bring to microfield day or a park and
Absolutely.
goof around with and people get a kick. And here's one of the secrets of all of these types of antennas. And I wish Ben was here to back me up on this. If you find something weird that works and it's funny, get witnesses and then never do it again. Because like the toaster oven, it'll become legendary. He has another thing he was gonna bring tonight. He will have it on Sunday. Remember those Torchier lamps in the 80s with the 500-watt halogen bulbs they all have? Absolutely magnificent 15-meter in vertical. Great, it's efficient. Don't go spending money on a vertical. Go to a thrift store and just, don't plug them in. They take more power than a whole house full of LEDs.
He's also fired up Christmas lights.
Oh, yeah. Christmas lights are fun because, you've got waves in what you're doing. Those light up bulbs.
We had success with the metal gutters, house gutters.
Metal gutters are a big one. Especially if you have a situation where you can't build antennas in your house, but you've got metal gutters, you're living
Right,
in
it's too
antennas.
long. I have to have a tuner.
You do need a tuner.
Yeah.
And I want to talk about tuners in a minute.
They're not that expensive.
But yes, an antenna doesn't have to be perfectly tuned. In fact, one of our very popular, especially for portable use antennas, are random wires that specifically are not resonant. The radio energy it really wants to find that quarter wavelength, and if the wire happens to be longer, it can ignore that part.
But aren't you as a ham trying to get 1-to-1? Why am I so crazy about 1-to-1?
Because hams fetishized SWR in the last 20 years. 20
It's
years
not-
ago,
it's not just-
20 years ago, they didn't care about it so
Right.
much. Oh, no, it's not just you. Getting past the idea that everything is SWR is not easy.
I'm sorry, I didn't bring my light bulb socket.
I've done FT8 with a light bulb.
Wow.
A lot of people have, actually. One guy, Kevin Longford, made a video about it, and so everybody ran out and tried transmitting FT8 with a light bulb, and it turns out it worked.
Queen size bed frame.
Probably sideband, you wouldn't get a strong enough signal. Because obviously a lot of your RF or your signal out of the radio is being turned into heat, because it will light up the light bulb.
So one comment that I'd like to make based on his question, though, why do I need a tuner?
Hey, where do you
In the
get
old
the tuners?
In the old days, right, we just go to a different balance. We would change our impedance transform, okay, to try to make that antenna appear to the radio as 1-to-1.
So larger diameter or smaller diameter?
Not necessarily, right?
Boy Scout days are crystal set, and you had your foil, you had your tap whisper, what you did was sort of move that wire up and
Right.
down the coil in order to find the direction of the stronger part of the signal. It's being sucked up, the signals are being sucked up into the foil in order to transform the energy to the airpiece, to that diode.
But the bottom line is that we use ununs, we use balance, we use all sorts of things to change the way that the antenna appears impedance wise to our radio. Doesn't make it any more or less resonant, okay? It just means that the energy is being absorbed in that transform.
Yeah.
And that's what the real battle is. Why we want 1-to-1 is, and you can hear arguments all day long where this is right or wrong, but the argument is that anything that's reflecting back to the radio is not being transmitted. The other argument is if you have a tuner there, it's gonna have to go back and forth, some of it's gonna get used up with heat, but that energy is eventually gonna go out the antenna. The reality of it is that if you're able to talk to who you want to talk to, it doesn't matter as long as you're protecting your radio. I'm sorry to interrupt, but I couldn't.
I agree with how you ended that. It really doesn't matter. If you're on the air and you're talking to somebody, it's a win. We are not in commercial broadcasting. You've done things where this really matters. You know, the efficiency has to be there if it's commercial broadcast.
Well, 1-to-1 is only where the meter reads.
Yes,
That's.
Exactly.
Yeah.
20-to-1, 10 feet away from the meter on the floor.
sure. And if you change the length of the coax to some fraction of the wavelength of it, you're gonna get a completely different reading.
And then some people put the tuner next to the radio, some people put it at the base of the antenna.
Right.
You said it was easy, simple.
Well, we need a place.
No,
That's
that's
right.
the stuff we're doing right now isn't gonna be.
It's
First
great,
off,
this is
I
great.
really wish that we would lose the phrase antenna tuner and wash it from hand radio completely. It didn't used to be there. They used to be called impedance matchers or matchboxes or all kinds of things, because that's what it does. It takes an antenna that doesn't match your transmitter and makes the transmitter safe. It's not gonna change the antenna one whit. And as you pointed out last night, even then, people that know that don't understand it. They think that that lost energy is going into heating the tuner. It's not. Warming your coax up. But it's not radio based. A bad antenna with a tuner on it that looks like 1-to-1 is still a bad antenna.
Right.
And that's okay. I mean, if I'm gonna do this on Sunday with things, I'm gonna have a tuner on my radio. And it'll go whackety, whackety, whack and make noises and press needles and say, look, it's 1.1. The antenna's not gonna be any better. My radio will be safer.
But the only bad antenna is the one that's not in the air.
Well, a bad antenna is one that is not efficient. Yeah, look at that. Efficiency is a defined value, and it's not an inherent quality. So define efficient for an antenna. Is the purpose of this to make everybody smile and go, how about that? It wasn't that funny? If that's the design goal, that was very efficient. If the design goal is to have the highest percentage of my transmitted energy be RF, and no, that's stupid. Because why would you use a radio as an antenna? No. Remember that when people say that, well, that's not very efficient, you'll get a lot of cranky old hands when they talk about random metal objects or your first antenna that you're trying to build. You want to make a plain wire dipole and just throw it on the roof instead of put it up half a wavelength. You will find plenty of people on the internet that'll tell you that's wrong. You can't do that. There's a lot of really grumpy people in ham radio because in real life, nobody will let them talk to them anymore. So they're hams. You gotta watch out for them. And no, the fact is that bad dipole still good enough to talk to people. So your first antenna doesn't need to be efficient in terms of converting the radio's energy into RF. And it doesn't have to have a perfect thing. It has a different measure of efficiency. And very high on what makes that one efficient is that you're a new ham and you got on the air with it. That makes it an excellent. I still have some really bad antennas that I built in my house because they never work. And then I got a nice multi-band Hustler vertical, and what I found is that some of these crummy dipoles that I had thrown on the roof on a specific band, they're still better than the nice commercial Hustler. Now, the Hustler has a different measure of efficiency. It's not how great it is on any one band, it's that there's 5 bands on one piece of coax. That's pretty handy too. So you give up a little bit of your ears for some convenience. Because, you know, neither one's better. They're just different. You notice I was playing with this. It's a fun thing I like to play with. It's just hooked onto the end of the coax. That's on the center conductor in red. The black one's on the shield. That's usually so that I can most of the time get them hooked up right. Sometimes that doesn't even matter because I don't plug in the coax. Somebody was asking about rain gutters. I'm only hooking up one thing because this is just the shield of the coax extended. I can just do this and it's a really, really good 440 band antenna. So I could, you know, if I could flip that onto the little wire inside my handheld, it kicks butt on 440.
What about the whiteboard?
That's what we're going for here. The pen tray, little miniature version of rain gutters. I'm going to start with something we know that this isn't going to be tuned for, say 440. How does this thing work? Wow.
I think Stu made a video on how to.
A couple, actually.
Well, we have one peak a bit lower than what we wanted in the 120 megahertz. So we could use it for linking repeaters. They use that band a lot. It's an awful lot longer than a proper antenna for that would be, but that frequency is willing to grab that out of that big longer piece of aluminum. Let's keep going up higher here. You'll find any given piece of metal, there's a bunch of stuff you can get it to work on. Heading now for 6 meters. Let's see what we got there. Oh yeah, 1.5 to 1 and 6 meters.
Wow.
I'd transmitted to that. Wouldn't be afraid to at all. $10 is a little closer to a 3 to 1. That's a little sucky. Try 20. 20 is really forgiving. Seems like we just manufacture a lot of stuff that 20 meters lengths.
Keith, if you move the clamp towards the middle, does that affect anything at all?
It'll become off center fed. Not literally, but yes, it does change it. If you really want to see funny stuff, you can start hooking the other clamp up in a different spot on it. Because one of the principles of radio that everybody should know is that AC is really weird. And you can have one piece of metal with the 2 clamps on it, and at certain frequencies, it'll think it's 2 pieces of metal that aren't connected. Oh, hey, let me move that a little more because we're one to one at 15 megahertz right now.
Can we hear something?
Unfortunately, no. There. Go ahead. There we go. 1.7 to 1 in the 20 meter band. So if you have rain gutters, they're not. You know, I'm sorry, one of these in a clamp, you could probably find spots in there that would be workable. And you don't have to explain an antenna to the HOA that isn't even an antenna. Wow. So. And again, efficiency. Not bothering the HOA. Make that the measure of efficiency, you can get really high.
Absolutely.
Yeah. Martin brought the vegetable tray from his refrigerator. See what this does.
You expose that.
Yeah, Stu graciously has scraped off a little bit of the vinyl for us here. Thank you, Stu. Well,
With his permission. Here, give that to me, I'll mix it.
I better check on your bands here first. We'll try 40 meters.
Too bad you can't try transmitting on that thing.
Yeah. We will on Sunday, and I apologize for not doing it here, but yeah, on Bozo's frequency, it's only 1.7 to 1. And yes, with a handheld, I would happily transmit into 1.7 to 1. Yeah, I can't tell you how much RF it is going to send out into the air, but I'd be pretty confident with this, it actually would be pretty good.
But it also shows the inaccuracy of trying to use SWR as a quality merit.
Right, I should have brought a dummy load.
Yeah,
So I
exactly.
could do the same experiment with a dummy load.
Yeah.
Because it's dissipating it as heat, there's no return reflected energy, so the standing wave ratio, the ratio of out to in is really good, but it's not transmitting.
Well,
There's-
isn't objects like this as they
Let me look.
have decent SWR, so we know the impedance is getting close,
Yeah.
right?
Yeah.
But they don't radiate very efficiently, they're kind of a dummy load in themselves. Getting closer to dummy load, right?
We didn't see the VLC.
Like down into the ground.
Yeah, I'll have to find the BNC UHF in here.
Is that a BNC?
Yeah.
You could just plug the BNC, right?
Yeah,
So,
oh, I need a gender changer.
this is a team.
How about that?
It's always amazing to watch these, you know? The one nice part is we're certainly unrehearsed here,
Yeah.
and it's a lot of fun.
Oh, yeah, right away, it doesn't even matter what frequency I pick it on, it's 1.1. That's a dummy load on the end. The way these work, by the way, is that they're little oscillators, they're little RF transmitters. Very, very low power. But it's literally sending a miniature version of what your radio is doing. So if it says 1-to-1, that's exactly what's gonna happen with my radio on it. One thing about dummy loads, unless you spend a lot of money on them, they're not perfect, they still radiate. And if you spend a lot of money on them, they just radiate less. I've never seen them radiate 0. But if you're testing 2 radios at home, the idea is to put a dummy load on the one you're transmitting with, because you're still going to receive it on another radio in the same building.
Sometimes I put a dummy load on the end of the coax, but I don't know if my coax, I will kind of just check a run of coax.
Mhm.
And I'll put that security, the flap across the hand down.
Right.
So it's also a quick way to check your coax.
Right.
Your connections, you're hooking something up, through a dummy load on.
Mhm.
So if you have a
Right without the
really
antenna.
long piece of coax, don't put something on it and see where the coax is resident. Because the coax will be resident in different areas of the band. Just by the sheer length of the coax. There you go. Yeah, it's.
Another thing that comes up sometimes, we just have this talk, that if you can't get good SWR out of your radio, have longer coax. It won't fix it, but it'll measure better. So you can feel better about it. You know, the loss from the coax will mask reflected energy. So I wonder what would happen if we go back to this. We knew it was pretty darn good at 2 meters. Can you hold that up vertically, please?
Hold it up now.
Right now, the counterpoise we're using is, 60 feet wound up in a big pile and a mess on the floor. I'm just gonna stay on this particular frequency at 122 because it's down to 1.2 to 1. Put on a shorter counterpoise instead that he was handing me. Just got worse, 1.7 to 1.
But see where it is resident.
Yeah, but we fussed an awful lot about counterpoises on radio. Your coax might do a better job than all those things. Don't be afraid to try it. It's not resonating anywhere. Nope, we ruined it. Oh, here we go. Here we are back at we're 1.5 or better from 110 to 126, 130.
But this is the counterpoint right here, right? That's the black water.
Oh, yeah.
So.
I'll show you what CVARC can know.
One thing that's true that we're gonna get to in a second here, it's not that critical.
Right, well, it's amazing.
That sine wave going through there,
Right.
alternating currents. It'll be the other way. It's like,
It's true, as long as it's opposite, right?
let's see where we are here. I may have,
God, my arms get tired.
unfairly insulted Britain's cocktail steward here. No, it still blows across the whole band. It still sucks. So who's got a mag mount 2-meter antenna? Everybody? You know, you can stick it on something like this for your counterpoise and it works. Why doesn't this work?
I got the cat right there.
That's a pretty sad cat. If it's gonna work as a counterpoise, it's gonna work as an antenna. If it's too big, remember, we already saw that it'll take part of it out of there. And, well, I could still get my 19 inches or whatever, even if it's not in a straight line, maybe it'll do that. And especially when you get into higher frequencies, we see them all the time, plate antennas are a thing. And they can be smaller than the main frequency you're doing. Let's get this done. And Bozo's frequency, we're at about 1.6 to 1.
That's amazing. Yeah, I'm sitting there snipping 1/4 inches off of my dipoles trying to tune them in. I'm going,
Mhm.
what? Why does that work?
I'm not saying you shouldn't,
Right.
because we're just looking at SWR. We're not looking at how well it's transmitting. But I know from experience.
What's the X say about it?
Pardon?
What is X say about it?
X is 0 right now.
Wow. That means it's really good.
Rich, also, this is up in the hundreds of megahertz, and you're dealing in 7 megahertz.
Right,
Far more
that doesn't have a
sensitive.
lot of, so
A little.
counterpoise, you're trying to provide something to make the RF go up, right? That's not very big. That, I would think that would work better.
Well, yeah,
Counterpoise has a lot more to do really with the radiation center. You can fix the SWR just by changing length of the primary.
And in many cases, the counterpoise is making up the other quarter wave of the
Yeah.
antenna.
Well,
So,
whatever's making up the other quarter wave, that's what I'm calling counterpoise.
place for it, you know.
Yeah, and if you don't provide something like, you know, the radial sticking out of the bottom of a vertical, for instance, a ground plane.
But if you're putting your
It'll pick
mag
up
mount on there,
something.
that's the counterpoise, right?
the other thing, of course, to remember is if you're using a long wire, there's basically you're going to ground.
Mhm.
So you're actually going to ground on the ground side or the shield side of the coax at the antenna, or at least that's the way it should be, unless you're running counterpoise, right?
Yep.
So that's just between an un and a bound at that point during your transform.
This one is interesting, a bit larger plate. I have very good SWR, Bozo's frequency, but the tiniest adjustments, the X value is going from 0 to 30. So you probably wouldn't want to use one of those in the real world because it's just way too finicky. But if you need something to stick your mag mount on, next time you throw away a computer, keep the side panel.
But for my situation, I can put a mag mount in my, up in the attic.
Mhm.
As long as I had room at the peak, and theoretically, it would work.
Attic antennas are pretty popular for people that have HOA restrictions and stuff like that.
And I bought one of those serial antennas, so it's like $130, best antenna I ever bought. You know, I'm thinking maybe that, something like that.
If your mag mount works on your barbecue, try loading your barbecue. Because if you got 2 meters working with the mag mount on the barbecue, you're probably gonna get a pretty good antenna out of the barbecue. Probably. And it'll be pretty good.
I have a question for you.
For a time, they were marketing those, little, rat tail antenna or, radios that would hang off of an HT, you know, as a counterpoise. I never found a way to measure if whether or not those things were effective or not. Did you, do you have an opinion on that?
Yeah, I think Kenwood and Yesa and everybody else have put an awful lot of money into designing radios to be the best they can be, and that you're not gonna fix it by giving some guy an eBay $4.
Yeah, I've never bought one, but kind of wondered.
Yeah, they've already figured out where it's gonna get its counterpoise from, you know, from your hand and.
And where's the counterpoise on this guy?
Well, there's such high frequencies, the whole antenna is tiny.
There's actually a dipole.
Yes.
I was hoping for.
Well, I'm gonna be,
Yeah, no,
I'm gonna be pedantic there. If it's an antenna, it's a dipole.
well, that's actually.
So most of you know I'm a musician. I have loaded up trombones lines anywhere from 2 to 6 meters. I didn't bring one in because most of my trombones are a little too expensive to mess around with like this. And the only time I can do that is when I have the lacquer removed enough to be able to get conductivity on them. Unfortunately, most trombones really make incredibly high quality antennas on 4 meters.
Badly don't have.
Yeah, it's great if you're English. Not in England though, I mean, there's not a lot we're gonna do with 4 meters here. So I didn't bring one of those. But I have a lot of guitars.
Oh.
Guitars are made out of little antennas. So let's try just the first string here.
Do experts get to use the E string?
Yeah.
What is the E string and megahertz?
Oh, just what a surprise here. We know we want our 2 meter quarter wave to be around 19 inches, right? Guitars 23, 24 inches. And yet on Bozos frequently we're 1.5 to 1. Ballpark's good enough most of the time, especially at 2 meters.
work on a folk guitar?
Yeah, no classical guitars need to fly on those. The cat guy just doesn't conduct well enough. But I'm hooked up on, you know, on the top, hooked on the top end of the guitar up there. And by the way, if you try this with electric guitars, you'll find out that the metal bridge shorts up the strings. But I'm gonna take a little clamp and make the first 2 strings there, so now I've got twice the length double back. I have no idea what it'll do. It's gonna be a whole bunch of capacitance because they're parallel and close to each other. But hey, what do you know? Now on Bozos frequency, it's 1.0. That's worth adding on to. Let's take that string and short it onto the next one.
If you have a harp, you can tune anything.
Yes. Yes, they're called log periodics. Yeah, let's try some other bands here. With 3 strings now. Oh, this guitar is only about 2.5 to 1 at 6 meters. That's not great. But you could use it. If I'd started with heavier strings on the other side, what would change, do you think? Yeah, bandwidth. When in doubt, more clamps. We've got 1, 2, 3. Let's connect that to the 4th string on this end.
Does it change if you use a cable?
Yes, yes, if you have metal frets. Yeah, you've turned it into whatever our first length was there, except it's really broadbanded now because it's all 6 strings are trying to go. So, good question. You know, now we're a little over 2 to 1 on 6 meters. That's doable. I'd put money on the fact that he does. There, we got 5 strings going now. Still about 2 to 1 on 6. Let me take a look at 10. 10 meters is about 2.5 to 1 more strings. Okay, that's all 6 strings there. No, we're not gonna get 10 out of it. Let me go back and look at 6 again with all strings. No, not quite as good as 5 strings. So on this one, the limit's about 5 wind-up strings in a really bizarre, highly capacitive arrangement. I have no idea what you call an antenna like that.
And then you're loading, you know.
Linear loading? There you go. I knew there was gonna be a name. Now, of course, I'm just using the shield on my coax here. If you want to have a better antenna, you really want your counterpoise to be nice and matched, right? So, all you need is more guitars.
How really is it?
I can get it go right to 5 on this one.
Would that make it a Fender broadcaster?
Oh, Leo knew all along, didn't he? Yeah. There, now we got 5 on each. Let's see, make sure I'm on the right post there. Yeah, you know, we have a marginal improvement on the SWR on 2 guys.
That should go on the website.
SWR improved slightly on 6 meters, but I'm sure it would be more efficient as far as.
Hey,
And
Keith,
hey,
quick question.
come on, it's a bunch of guitars.
Keith, can you take a question?
I was transmitting on these on 6 meters a couple of days ago. And I can get the repeater to chunk back on me and written on me. So I didn't talk to anybody, but it was enough going out that it triggered the repeater. So, you know, I'm not looking for a good antenna on my roof. I'm measuring the efficiency of this one by, well, that's kind of. So there we go. Did anyone bring any other stuff? Oh, you got it.
How about this?
Yeah.
Is there any bare metal in here?
Check it out. There's an antenna.
There's some bare metal in here.
We can make some bare metal.
You know,
You can use that, I'm gonna hold for ticket.
yeah. Again, paint doesn't conduct that well. I am gonna take the clamps off these strings.
Yeah.
Cause I only change my strings every 5 or 6 years. I hate to break them.
Pain in the ass to tune up too.
And the guitars are for sale.
So, the next class, how to do the FCC exposure tests on those.
Yeah,
We won't tell if you will.
There's a warning for.
yeah. I couldn't hear you, Joe. Hope you give me a reason why you want to actually play with this stuff, because I think it's silly.
Absolutely.
Yeah,
Great point.
yeah. I mean, you might have to put your radio in the trunk of your car and leave your house for a few days. Maybe you still want to try and get a hold of somebody with HF.
So at the Reagan Library, we loaded the barbed wire that ran alongside the road that went up to the helipad. And at between 2 AM and 6 AM, the operator made 360-meter contact with the barbed wire. Wow.
Barbed wire is a pretty
No,
popular.
let the rust there. I think it actually enhanced the signal.
You need something that walk to 160 jumps.
Barbed wire fences are very popular to use by short-wave listeners.
Yes.
And there are major exceptions to what I'm gonna say, but if you can receive on it, you can transmit on it. Got the great big old asterisk on there, but, I mean, maybe not well, but enough to fool around, sure.
So the one thing I will say though, is difference in designs between receiving and transmitting antenna.
Mhm.
And the beverage antenna comes to mind. There's an antenna that you never want to try to transmit, however it receives wonderful. And it was originally invented, I believe, in World War I.
Right, but yeah, and the guy's name was Beverage, by the way, if you're wondering
Yeah.
why it has such a strange name. There was a person whose name was Beverage. I'm not even gonna look any further on here because we're 1.5 to 1 on 10 meters.
Oh.
Yeah, on the trolley. With a coax counterpoise. But I guarantee you'll be able to at least do something like FT8 with it. FT8 is fun for random metal objects because weak signal can still be.
Although, if it was outside, it would be better than if it was inside.
Yeah, if it was up vertical, I could get a different rating of it, if I was
Yeah.
standing further away or closer. Everything that's subtle and complex about antennas is still going to apply. I don't mean that none of that stuff is true. But I mean, for hams, for playing around and being silly, it's okay to look at antennas as being simple.
So is there gonna be a random metal object field day this weekend?
Yes, there is. On Sunday, as a matter of fact, because there I'll be putting all these things on the air. Come by on Sunday at the Camarillo Airport, at the Fire Department Training Center. The ordnet.net website has the directions and GPS. Bring anything you want, and we'll just see how silly and stupid we can be. Any questions?
Can you direct bury coax?
Can I what?
Can you direct bury coax?
If you buy coax, it's made for direct burial.
Okay, so not all coax.
Most of it not.
That was good.
You'll probably have to pay quite a lot more for direct burial coax, but it exists. It's the thing.
Usually it's cheaper in the condo.
Cheaper and easier to replace.
Well, therein lies the problem. We just got done replacing some coax, it was in excess of 20 years.
Yeah.
Yeah, but there's a lot of coax out there.
And I have to say, we got remarkably lucky with the coax runs today.
Yes, we did.
From the roof to that room. And it turned out we only had a few feet of pipe. Yeah.
You need a phone number.
Hmm?
You didn't need a phone number.
No, there was enough room to just stuff it. Well, we'll pull it through with the old piece of coax is what we did, but it had enough room for the fittings.
Right.
So that turned out to be the easiest part of it.
Yeah, actually,
Yeah.
I only had to terminate it twice.
So much for your video.
Okay, thanks.
Thank you.